Good morning, everyone. In our last class, we are doing sums of conditional probability and total probability. So, what is conditional probability? When we talk about conditional probability, I'm saying that one of the event A has already occurred. Keeping in mind, we are going to find out the probability of the second event. So, symbolically, we write probability B given A. A is the first event that has already happened. B is the second event that I need to find. The formula is intersection upon A. This was conditional probability. Then from here we found out compound probability, which was basically nothing but shifting of the denominator. P of A into P of B given A. Right? Now we talk about sums of a conditional, total, and base theorem. So how do we know which one is which? So we don't need total probability and Bayes theorem formula in general, but we'll be doing the sums directly. So when we have single event, it's a normal probability favorable by total. Supposingly, I have a bag which contains 5 white and 4 red balls. I have a bag that contains 5 white and 4 red balls. Now, if I say what is the probability of getting a white ball? One single event, and directly I'm asking you to find me the probability of a white ball. So in that case, we use the normal probability, that is favorable case by total case. Total balls 9. What I want is white in color. So white color, I have 5 balls. So answer would be 5 by 9. Yes. Now, if I would have said that I'm picking up 2 balls, 2 balls are picked up at random, what is the probability that both are white? When we have more than one object, we use combination. So first we have favorable, then we have total. So in total is 9 ball and you are drawing 2 ball. Whenever we draw more than one object, we use combination. So out of 9, choose 2 balls. So out of 9, choose 2 balls. This is total. Numerator will be favorable case, the color that you want. We want white ball. So white ball is how many? 5. From that, you need to have 2 balls. So that will be 5C2. So if it is only selection of one object, we can directly write favorable by total. If it is selection of more than one object, in random cases, without replacement cases, we use combination. Now, this was normal probability. Then we came to conditional and all those where they will be talking about two events. When we are talking about conditional probability, I'll tell you both. What has happened first and what are we asking you to find? So suppose I have drawn a ball. I've already drawn a white ball and I threw that away. Now, keeping this in mind that I've already drawn a white ball, what is the probability that you will get a red ball? What again? From here, I have already drawn a white ball. So if I have already drawn a white ball, that means the quantity of the bag has changed. So now in my bag, I have 4 white ball, 4 red ball. Now from this, what I'm doing is I'm picking up another ball again, and I want that ball to be red in color. What will be the probability of that? 4 by 8. Symbolically, we write probability red ball given white ball has already been taken out. If I would have asked you probability red if red was taken out, if earlier the first ball that you took out was red in color, in that case, the denominations would have been 5 white and 3 red. Now, from this, getting a red ball probability would be 3 by 8, right? So, probability of the second ball, probability of getting a red ball in the second pick will completely depend upon which colored ball you picked up in the first one. So, this is conditional probability. How do we know that? I told you two events, first ball, second ball, and I told you which color are both. I wanted my first ball to be, say, white, and now I want my second ball to be red. So you need to find the probability of the second event, keeping in mind that the first has already happened. So this is conditional probability. When I'm talking about two events, I'll tell you what both the events are, and I'll ask you to find the probability of the second event. Again, whenever there are two events, there are three possibilities: conditional, total, or base. We have only studied conditional till. So in conditional, what will happen is I'll tell you both the events. What is my first event? For example, white ball. What is my second event? Red ball. And I'll ask you the probability of the second event. What is the probability that the second ball would be red in color, provided the first ball that you picked out was white in color? That means from the bag, one white ball has been removed. Whatever is remaining, from that we are picking up a red ball. So we don't need a formula. We can do it normal by common sense also. This is conditional when both the events will be given, first event as well as second event, and you will be asked to find the probability of the second event. Any doubt from you? Everybody clear till here?
Yes, ma'am.
Yes.
Now, what will happen when we talk about total probability or Bayes theorem? Understand. I have a bag. I have 5 white and 4 red balls. Hear the question and tell me what is the difference from the earlier question. What was my earlier question? A white ball was picked up at random and thrown out. What is the probability that if I pick up a second ball, that ball will be red in color? So I told you two events. First event was white ball, which I've already thrown. The second event is getting a red ball, and I only want you to find the probability of the second event. This is conditional. Now my second question, what I'm about to ask. A ball is picked out at random and thrown away. From the remaining quantity, we pick up another ball. What is the probability that the second ball you pick up is red in color? What is the probability that again, a ball is picked out at random from the bag and is thrown away. From the remaining quantity, we pick up another ball. What is the probability that the second ball we pick out is red in color? So again, two events are there. I'm picking up a first ball and I'm picking up a second ball. I do know that the second ball has to be red in color, and that is what I need to find also. So it looks like conditional, but why is it not? The first ball is not mentioned. Earlier, when I said that the first ball that I threw away was white, so I knew my first event, I knew my second event. You asked me the second event. That was conditional. Here, yes, there are two events. Yes, I'm asking you to find the probability of the second event, but I did not tell you what my first event was. Did you all understand the difference here?
Yes, ma'am.
Yes,
All of
ma'am.
you? So, whenever first event, there are two events, first, second. First is missing. You don't know what's the answer. And I ask you the event of second, probability of the second event. This is total probability. Okay, a normal scenario. So you do the first event, whatever has happened, keeping that in mind, I'm going to find the probability of the second event. So it's a normal straight route. First hoga, then I'm finding second. So this is total probability. Why is it different from conditional? Because the first event is not mentioned. Understood? Now, first ball will happen, and then you need to pick up a red ball. Isn't this what is happening? Now, the first ball is not mentioned. Can you find the probability of the second ball to be red if you don't know what happened in the first one? No. Why? Because it will change the quantity. So now you tell me what will happen here. We need to consider every possibility. So I start my event. What's my first event? To draw a ball. Do you know which color?
No, ma'am.
No, ma'am.
So what are the two possibilities?
White and
Red and white.
So it can be first white and then second red. Because see, second event is fixed. Second has to be red. Only the first one can vary. Or what can happen? First is red and then you're picking up the second ball to be red. Do you all agree?
Yes, ma'am.
Yes, ma'am.
So to get probability red ball, second red, there are two possibilities. Probability white in first and red in second. Or means plus. Probability red in first and red in second. Till here, everybody understood.
Yes, ma'am.
All of you understood all the non-maths ones.
Yes.
Okay. So now, since we have to do both the events on our own, can you tell me from this bag, the first case, You need to pick out a white ball first. What is the probability that the first ball that you pick up is going to be white in color?
5/9.
5/9. So if you have picked out the first white ball, so the remaining balls are 4 white and 4 red. Now from this, you are drawing a red ball. What is the probability of that?
4/8.
And I want both of them to happen for my event to be complete. So multiply because there is and. Any doubt till here?
No.
Or again, starts again. We want to find red, the first ball to be red. What is the probability that the first ball would be red?
4/9.
So now red ball has already been drawn and thrown away. So now remaining 5 white and 3 red. What is the probability that the second ball is red in color?
3/8.
3/8.
This is total probability. This is total probability. So what was conditional? First event you know the second event. I'll ask you the event of the probability of the second event. What is total probability? First missing, second you know, and I'll ask you to find the probability of the second event. Till here, everybody clear?
Yes, ma'am.
Okay. Now what will be Bayes' theorem? This is total probability. You don't need formulas. I think it's well understood without formula also.
Yes, ma'am.
You won't find it in your book also, but you get sums in exam. This total probability sum you will still get. Bayes theorem sums are not there in the book, neither in the module examples nor in the exercise. But if you see the past year papers later on after the syllabus completion, when we'll do the past year questions, you will see that Bayes theorem questions have also come occasionally. So make sure, because it's just one line extra. So we'll do that also as an extra. So till here, everybody clear? Now, same question. Understand and tell me what is the difference. A ball is picked out at random and thrown away. You draw another ball which is found to be red in color. What is the probability that the first ball that you picked up was also red in color? Again, a ball is picked out at random and thrown away. From the remaining quantity, you pick up another ball and which is found to be red in color. Okay, so till here, I think it's the same like total probability. First event missing, second event is red. Now, what will total probability ask you? Probability of the second event. What is the probability that your second ball is red in color? This is what they'll ask you, right? Now, this part changes. What is the probability? I won't ask you about the second. I'm asking you, you picked up a ball at random, you threw that away. From the remaining quantity, you're picking up another ball. That ball is found to be red in color. What is the probability that the first ball that you picked up was also red in color? So in this case, this is the first time I asked you the probability of the first event. In conditional probability, I asked you about the second event. In total probability, I asked you about the second event. Only in Bayes theorem, I asked you to find the probability of the first event. I send you back. That go back and tell me what happened earlier. Did you understand the difference?
Yes, ma'am.
So what happens in Bayes theorem is probability red has already happened. The second ball has already happened. So what will happen in Bayes? Probability first red given second red. This is what I want to find, but this is completely contradictory to the actual way we write. Because how can I find the event of the probability of the first event knowing that second has happened? This is not the general order, right? You are making me go against the normal routine, right? Whenever you ask me to go against the normal routine, that is Bayes theorem. So in that, what we will do is the total probability that you get in red in the second event, we will write that in the denominator, this that you obtained. You wanted the second ball to be red. The first event could have been anything. First white, second red, first red, second red. You found that out. That will be in the denominator. Okay. Now, what you want? You want your first ball to be red in color. Which term is that? First red. This was the first red, first, second red. This term, that will come in the numerator. So we write the total probability, second red probability in the denominator. From that, whichever is the term that belongs to your favorable case, you write that in the numerator. So all of them will have the same denominator, cancel. So 12 by 32 would be the answer. Did you all understand this? We'll do another example, you'll understand from that. Till here, to some extent, I think you understood the difference of the question.
Yes, ma'am.
Let's try again. Let's try again. There are two bags. There are two bags. First bag. This has 5 white and 4 red ball. Second bag. This has 4 white and 5 red. Now here's the question. What is the probability that a ball is red in color if it was picked up from the first bag? What is the probability that the ball is red in color if it was picked up from the first bag?
4/9.
Which case is this? Conditional, total, or base?
Total probability.
Wrong. It's conditional.
Conditional.
Yes, you know both the event. You know that you are picking up a red ball. If first case was choosing the bag. I had two choices. I can choose the first bag. I can choose the second bag. Which bag are we choosing? We are choosing the first bag. Which ball are we choosing? We are choosing the red ball. So there are two events, choosing a bag, choosing a ball, and you know both of them. First bag, red ball. So when you know both the event, that is conditional. So from the first bag, I don't even need to choose the bag. They have already chosen it for me. From the first bag, what is the probability that the ball is red in color? 4/9. If I would have asked you, what is the probability that a red ball is picked up from the second bag?
5/9.
5/9. Understood? So when I tell you both the event, that is conditional probability. Everybody clear?
Yes, ma'am.
Yes, ma'am.
Okay. Second question. A bag is picked up at random and a ball is drawn from it. What is the probability that the ball drawn is white in color? A bag is picked up at random and a ball is drawn from the selected bag. What is the probability that the ball drawn is white in color? Again, how many events are we talking about?
2 events.
What is the first event? First
Choosing
event,
bag.
choosing the bag. That is, see, if I will be doing the job, I'm standing. I have two bags in front of me. The first thing that I need to make a call is which bag, right? So either the first bag or the second bag. Did they tell you which bag?
No.
No. So first event is missing. Then whichever bag I choose, from that I need to pick up a ball. Do you know which color? I told you what is the probability that the ball is white in color. So I want you to find a white ball. So I know the second event. First event was choosing a bag, which is unknown. Second event is choosing a ball, which is white. And I have asked you the probability of which event? Second event, white ball. So first event missing, second event known. Find the probability of second event. This is
Total probability.
total probability. Everybody clear?
Yes, ma'am.
Yes, ma'am.
So first bag selection. So I can choose the first bag and then I can select a white ball, or I can choose the second bag and then choose a white ball. Everybody understood with this? So probability first bag, and white ball, or probability second bag and white ball. So first you need to select the first bag. There are two bags. What is the probability that first bag will be selected?
1 by 2.
1 by 2. There are two bags. You need to select the first one. 1 by 2. We got selected the first bag. From the first bag, what is the probability of getting one white ball?
5 by
5
9.
by 9.
Multiply 5 by 9, or choose the second bag.
1 by 2.
By 2.
And from the second bag, choose a white ball.
4 by 9.
This is total probability. Clear?
Yes, ma'am.
Again, a bag is chosen at random. From the selected bag, a ball is drawn which is found to be white in color. What is the probability that the first bag was chosen? What is the probability that the first bag was chosen? First event unknown, second event is white, and I asked you to go back and find the probability of the first event. Which case?
Base theory.
Yes,
Base
theorem.
theorem. What will I do?
Total possibility will go to the winner.
This is the denominator. And what will be in the numerator? I want the first bag. First bag option is the first term. That will come in the numerator. Understood?
Yes, ma'am.
Everybody
ma'am.
understood?
Yes, ma'am.
Okay, let's discuss the examples. This base theorem part is new. It's not there in your book. We did till 15.21. We'll start the examples from 15.22. Page number 15.24. The first line itself tells us that the events are independent. So what does independent tell us? For every intersection, you will be able to write multiplication. The independent probabilities that the three sections of costing department will encounter a computer error are 0.2, 0.3, 0.1. So these probabilities are making an error. These probabilities are for making an error. What is the probability that at least one computer error per week is conducted? At least one is what? Union. Also, at least one. That means there should be one error at minimum. There can be two, there can be all three error also. But there has to be a minimum of one error. So there are so many cases. One error may occur, two error may occur, three error may occur. Rather than that, what is the opposite of that? No error. Right? That is the only problem that I have. That is the only thing I don't want. I don't want for a case to have zero error. So from total, I'll remove zero error. So 1 minus, first one will not make error. Making an error was 0.2. Not making an error will be
0.8.
0.8. And second event, second one making an error is 0.3. Not making an error will be
0.7.
third one making an error 0.1. Not making an error,
0.9.
answer 0.5. 0.8, 0.7, 0.496. So 56. Answer is 0.496 precisely, whatever is in the option. Second one and only one computer error. That means there should be exactly one error. So what will happen here? What are the cases? One and only one error. So I can have an error in the first one. In the other two, I won't have an error. I may have an error in the second case, not in the first and third. I may have an error in the third one, but not in the first and second. Yes or no? So there are three cases. Error in first, or error in second, or error in third. So if I want error in first, I want an error in the first. What is the probability of making an error in the first one?
0.2.
0.8, 0.2. Not making an error in the second one.
0.7.
Not making an error in the third one. Plus. Making an error in the second one. Making an error in the second one. 0.3. Not, that means in the other two, I'm not making an error. First one, I'm not making an error. 0.8. Third one, I'm not making an error. And next case, error in the third. I'm making an error in the third one. 0.1. That means in the first and second, I'm not making an error. First one, no error. 0.8. Second one, I'm not making an error. 0.7. Calculate.
0.374.
0.374.
Ma'am, 0.39.
1 second. Let me check. 0.398. This is wrong. 0.398. Check. 0.398.
Yes, ma'am.
Next, example 15.23. Example 15.23. A lot of 10 electronic component is known to include 3 defective parts. In 10, there are 3 defective, so 7 are good. If a sample of 4 is selected, so if I'm selecting 4 objects, what will be my denominator? Selecting 4 objects. So my denominator would be 10C4, total 10 objects, I'm selecting 4. Now, numerator will be what they want. What is the probability that the sample does not contain more than 1 defective? So there should not be more than 1 defective, but there can be 1 defective. There can be 0 defective. There are 2 possibilities. Probability 1 defective is allowed, probability 0 defective is allowed. What is not allowed is to have more than 1 defective. So I can have probability 0 defective or probability 1 defective. So out of 4, I have 0 defective. That means all the 4 are good ones. If out of 4 components, I have got 0 defective component, that means all the 4 components are good components. So select 4 good components.
7C4.
7C4.
7C4 plus. Out of 4, choose 1 defective. So if 1 is defective, then the remaining 3 will be good. I'm choosing 4 components. They have told you 1 defective. So that means automatically the remaining 3 are good. So 4 component, 1 defective, 3 good. Choose 1 defective item
3C1.
and 3 good items
7C3.
7C3.
by 10C. 7C4 is same as 7C3. 7 into 6 into 5 by factorial 3. That is 35. 3C1 is 3. 7C3, we just calculated 35. So 35 into 3 is 105. 10C4 is 10 into 9 into 8 into 7 by factorial 4. That is 210. So 140 by 210. 0.666. 0.666. Any doubts?
Oh, ma'am.
Clear? Example 15.24. There are two urns, two containers basically. First one has 5 red and 6 white balls. First one. And the second one has 3 red and 7 white balls. If two balls are drawn from the first one without replacement and transferred to the second one, from here I'm transferring two balls to the second one, right? And then a draw of another two ball is made from it. Made from it means made from the second one. So my first job is to transfer two balls from the first bag to the second. After transferring, I need to choose two balls from the second one. What is the probability that both the balls drawn are red? So which one did you transfer? Which balls did you transfer? No,
Unknown.
not mentioned. It's not mentioned. It only said two balls are transferred. It did not tell you which color. So it can be two red transfer, it can be two white transfer, it can be one red or one white transfer. They did not tell us which balls did they transfer. But after transferring it to the second container, from the second container, we are drawing two balls which are red in color. So first event is unknown, second event is choosing two red balls. And which probability do I need to find? I need to find the probability of second event. Which case is it?
Total probability.
Total. Everybody clear till here?
Yes, ma'am.
So first, what are the possibilities here? There are three possibilities. Two red transfer from first to second and then two red from second. Second case, two white transfer. Once you have transferred two red from second, one red and one white transfer, and then two red are drawn from second. Did you understand the cases?
Yes, ma'am.
All of you?
Yes, ma'am.
Yes, ma'am.
So probability. Now the first case, transfer two red balls from here. What is the probability of selecting two red balls that I'm gonna throw it in the second one? From two red balls. Two red balls. Two red balls.
5C2 by 11C2.
Total 11C2. From that I need to select two red balls. So if I have transferred two red ball, then the second ball bag contains 5 red and 7 white ball now. If I have transferred two red ball to the second bag, so now the second bag has 5 red and 7 white ball. Do you all agree?
Yes, ma'am.
Yes,
Now
ma'am.
from the select two red ball. Select two red ball.
5C2 by 12C2.
5C2 by 12C2. Favorable by total. Or second case. From the first bag, transfer two white. From the first bag, transfer two white. From the first bag, transfer two white. Clean slate, new start.
6C2 by 11C2.
6C2 by 11C2. Once you have transferred, the second bag will now contain 3 red and 9 white. What do I need to draw? I need to draw two red only. So from the second bag now, draw two red balls.
3C2 by 12C2.
Or one red and one white. From the first bag, transfer one red and one white.
IC1 into 6C1 by 11C2.
If you have transferred 1 white and 1 red, we now have 4 red and 8 white. From here, select 2 red balls.
4C2
4C2
by
by
12C2.
12C2.
4C2 by 12C2.
Everybody clear?
Yes, ma'am.
Yes, ma'am.
So 5C2, 10, 11C2, 11 into 10 by 2, 55. 5C2, 10, 12 in C2 will be 66. 6C2, 15. 11C2 is 55. 3C2 is 3. 12C2 is 66. 5C1, 5. 6C1, 6. So 30. 4C2 is 6. So denominator is same for everyone. Add 100 plus 45 plus 180. 325 divided by 55 divided by 66. 0.089. Everybody matches the answer? Everybody does your answer match?
Yes, ma'am.
Yes, ma'am.
Yes,
All of
ma'am.
you?
Yes, ma'am.
Next. 15.25. 8 balls are distributed at random among 3 boxes. So this is my total. 8 balls will be distributed in 3 boxes. How many total possibilities are there to distribute 8 balls in 3 boxes? So I'll start with ball. I pick up the first ball. How many options do I have to throw? 3 in any one of the box. I pick up the second ball. How many options do I have? 3. I can throw in any one of the box. Third ball, 3. Fourth ball, 3. So 3 will appear 8 times. So total possibility will be 3 to the power 8. All of you agree?
Yes, ma'am.
Any doubts still here? Now, what is the probability that the first box would contain 3 balls? This is favorable. So there are 3 boxes. The first box needs to have 3 balls. So first, let the first box have 3 balls. How many balls do we have? 8. Out of those 8 balls, 3 has to be put there. Which 3 we have to select? So what is my first job? Select 3 balls which I'm going to dump in the first ball. So out of 8 balls, select 3 balls.
8C2.
8C3.
So first box is done. That is full. No more balls can be put there. Is my work complete? No. I had 8 balls. I've only placed 3 balls till now. Remaining 5 balls are still left. Now those 5 balls has what option? Second box and third box. So from those 5 balls, I pick up the first ball. How many options? 2. Second ball,
2
2. Third ball, 2. So each one of the 5 balls will have 2 options. So in total,
2 power 5.
power 5.
so always make sure if you had 8 balls, you need to write every time for 8 things. If you have suppose 4 component, you want 1 defective. You won't only just write the probability of 1 defective. You need to also write the probability of the remaining 3 also. This is clear, guys?
Yes, ma'am.
Yes, ma'am.
8C3 is 56. This is 32. This is 6561. Calculate. 0.2731. Guys, any doubt?
नहीं, ma'am.
Done, everybody? $15.26. 15.26. There are three boxes. Box 1, 7 red, 5 white, 4 blue. Box 2, 5 red, 6 white, 3 blue. Box 3, 4 red, 3 white, 2 blue. One box is selected at random and a ball is drawn from it. What is the probability that the drawn ball is red in color? It's a case of
Total probability.
total probability. So now you need to tell me what are the different paths. Oh, yes. Online, I'm waiting for the different paths.
Box 1 is selected. From that, we are taking 2 balls.
Box 1, and then
2 red balls.
where is it written? 2 red balls. What is the probability that a drawn ball is red? Only one ball is drawn.
Oh, sorry, 1 red ball.
Then we have box 2, and then 1 red ball. Box 3, 1 red ball. Yes? So, probability. Select the first box out of the 3.
1 by 3.
1 by 3. Then select a red ball from that.
7 by 16.
7 by total red ball by total balls. Box 2, 1 by 3. From that, choose a red ball.
5 by 14.
5 by 14. Then box 3 again 1 by 3. Choose a red ball.
4 by
4
9.
by 9.
Calculate. Calculate. Answer. Probability can never go beyond.
0.413.
Sorry?
0.413.
Very good. 0.413. Clear? Everybody clear?
Yes, ma'am.
So this is the first part of probability that is complete.